Hello, Flame community. This is Jeff Kyle with the Flame Learning Channel. New to the Flame 2027 release are 2 machine learning depth models, giving us some powerful new 3D and segmentation workflows. In this video, we'll be covering where to find these new machine learning depth models and how to use them on your next project. We can find the new machine learning depth models in the image node, in the GMask tracer, as a standalone matchbox inside of batch, and inside of action. Here in the effects environment inside of the image node under this ML layer dropdown, we can find our 2 new machine learning models, depth indoor and outdoor. It's also worth noting that we have an option to load our own model where we're able to point to a trained inference or an ONNX depth model. The key differences between the two are that the outdoor model works best on footage with a clearly defined sky, and the indoor model works best on footage with a clearly defined confined space. When I select the model, it's loaded into the layer list, and when I use the F8 keyboard shortcut to view the image object view, we can see the depth in its matte form. We have 3 different segmentation types with context-specific submenus for each. Starting with distance, we have 5 different decay algorithms to choose from, as well as a near and far slider to adjust the clipping plane. The next segmentation type, near-far, is slightly different, also with near and far sliders, but also with a fall-off control to dial in the smoothness of the transition. Our last segmentation type, range, is yet another slightly different way of segmenting the depth data, this time more heavily leaning into the slice concept where we select the origin of the slice and then widen the range once we find the part of the image we want. And we finish it off with our familiar fall-off control for softness. If we know we're going to use multiple depth analyses, we'll want to use this Use Map button, which creates a Z-depth map that can be used for more than one depth layer, spanning multiple ML layers and multiple selectives, which helps with render efficiency since we won't need to perform multiple machine learning depth calculations. In this shot here that we've been looking at, if, for example, I'd like to bump up the atmospheric perspective in the background, it's a wonderful use case for some depth segmentation. I'll choose the range segmentation type, move the origin way back in space, open it up with the range parameter, add a slight fall off just to take the edge off. Now that my segmentation is ready, I can dial up the blue and maybe bring back some of the color in the clouds with the white tone controls here. And in no time, we have a relatively complex selection that is quite temporally stable with no keyframes or manual masking. The uses for depth segmentation are quite varied, but we are going to switch gears over to batch. Here in action, once we've pulled out a surface, if we pull up the contextual menu, head to Add Map, and add a Z-depth map, our surface will be ready to work with depth. By default, that Z-depth map is set to Media Input, which is expecting an external Z-depth pass to be fed into this action node, but if we look under the depth section and open up the drop-down menu for that Media Input selection, we can find our 2 new machine learning models, indoor and outdoor. With the ML depth indoor model selected, when we select the Z-depth map, and when we press the F8 keyboard shortcut to view the action object view, when using the ACES 2.0 OCIO config, we have access to this spectral visualization under the Z-depth view transform, but we can also switch to raw or matte to view the data as a grayscale. Under the depth type, we have an effect control to control the strength of the displacement. This slider doesn't affect the Z-depth map itself, but rather affects whatever parameter is being affected by the Z-depth. The next slider down, softness, is an overall blur that affects the Z-depth map itself. The Z-depth pass button passes the Z-depth through the action node and is required for most Z-depth operations here in action. Before it's enabled, if we take a look at the output of the action, under Z-depth, we're met with a blank gray screen, but once we switch back and enable it, we can see that the Z-depth data is being passed through and is able to be used. Displace vertices uses the Z-depth data to mimic the displacement of vertices in the scene without creating actual 3D geometry. This 3D button is similar to displace vertices, except it creates 3D geometry from the footage, driven by the Z-depth, allowing us to fake subtle parallax. Bump normals uses the z-depth map to generate new normals, and both this and the input type selection are only relevant for when we're using the media input depth type and when we aren't generating a machine learning depth map. Now let's take a look at some machine learning depth examples here in action. In this example, let's say we'd like to enhance the existing depth of field to change the focus of the scene just a bit. First, I'll pull out an action node, jump into the action schematic, and pull out the background surface. I'll use the contextual menu to create a z-depth map. Since this is certainly an indoor scene, I'll switch the type to ML depth indoor, and after just a moment, the ML model has loaded. I'll take a peek at the F8 action object view just to confirm it looks right, and I think we're good. Now, I can pull up the contextual menu for the camera and add a physical defocus matchbox shader. When I do, nothing happens, but if I switch back to the z-depth map and enable the z-depth pass to ensure our ML depth is being sent to the whole action schematic, we can see immediately the physical defocus starts to affect the image. Back in the physical defocus settings, I can enable the depth position icon to manually place the focus point to this part of the image, and then do a quick keyframe to ensure the focus sticks to this part of the image. And there we have it, enhanced defocus powered by ML in just a few quick steps. Now let's talk about how z-depth can work with 3D geometry and occlusions. Just like before, if I pull out an action node, jump into the action schematic, pull out the background surface, create a z-depth map, set it to indoor, and then turn on displace vertices. With this turned on, I can pull out any 3D geometry or light. In my case, I'll just grab a 3D text node and change a few settings to make it help make sense for this scene. And now, when I transform it in Z to push it farther back in space, we can see that the text appears to go behind the pillars. If I pull out a light, adjust a few parameters to make it work with this scene, we can similarly place it in 3D space to put it behind the pillar and in front of the text, and it acts as if the pillar is geometry we can interact with, all driven from the machine learning depth analysis. The interactivity goes quite deep in that I can even add a shadow caster to the light, and our text casts a shadow onto the floor, and of course when I adjust the light, we can see everything is interacting together, and we see the same when I adjust the text, all powered by that machine learning depth map. If we quickly take a peek over at our z-depth output, we can see that the 3D text I've placed is properly added to the depth output from action. There is quite a lot of power to this, and we're really only scratching the surface here in 3D, but I hope you got a good taste for what's possible with our latest machine learning edition. If you like these videos and you're finding them helpful, please subscribe to the Flame Learning channel and click the bell to stay notified about new content. Feel free to comment any questions or suggestions below. Until next time, thanks a bunch for watching.